Okay, so this is a video over 11.5 confidence intervals. So section 11.5, we're talking about the idea of a confidence interval. This is basically you don't know the true um, mean or true average of what something is. So you're going to base it off of your sample. And what you want to do is have a confidence of, say you want to be 95% confident that the actual population falls between here and here based on your sample. So you want a good sample of the population so you can get a good representation of what that is. So here's kind of the basic idea behind confidence intervals. A confidence interval indicates a range of values that's likely to encompass the true mean. So it gives us a range of values. Okay. So they're going to give you a confidence interval. The most common confidence intervals that you see, they can be other ones, but these are the most common ones, are 90% confidence interval, a 95%, and a 99%. So those are the three big ones. There can be other ones. Here's how these Z values are calculated then. Because it's a confidence interval, so you're saying it's between these two values. So what you have to do is split the two up. So when it's a 90% confidence interval, that leaves you 5% on each side. When it's 95%, that leaves you 2.5 on each side. And then 99, it leaves you 0.5% on each side. And then to get the Z values, let's say it's a 95% one. So where did this come from? So you do 1 minus the 0.95 divided by 2, which is that 0.025, 2.5%. And then if you do your inverse norm of each of those, it'll tell you the Z value that lies with. So we just wrote down the positive. It's actually plus and minus. But the 1.960 is what you would use for a 95%. Now, again, you can use these three. If it's something else like a 98% or something like that, then you can go through and do the calculations. But most of the time, all the problems will deal with these three big ones. Okay, so here's how you do your confidence intervals. Okay, you take the sample mean. So this will be given to you in the problem. This is the mean of what you got from your sample minus the Z value. This comes from the chart, depending on which confidence interval you're going to use. Then you're going to take that times the standard deviation, which again will be given to you in the problem. That's the standard deviation of your sample, divided by the square root of your sample size. Okay. And then you'll notice this is our true mean. On the other side, it's the exact same formula, but this side is minus and this side is plus. And that's where you get your interval of the lower and upper limit. And what this is known as right here is your error. And so what you're doing is taking that possible error and adding and subtracting it from both sides to see what that actual mean is in between. Okay, so let's take a look at example. These are pretty easy to do, not a lot of work here. So it says a sample of 65 randomly selected mall patrons shows that they spent an average of $70 that day with a standard deviation of $12. Find a 95% confidence interval for the average amount spent by a customer that day. So just basically taking this formula, filling everything in is all we're really doing. So $70 is our average. That's from our sample. The 1.96, I got that because it was a 95% confidence interval. If I look up here, 1.960 goes along with that. Times 12 because it was a standard deviation, square root of 65. And then you can see on this side, everything else is exactly the same. This side has a minus, this side has a plus. When I type all this in my calculator, I got 67.08. And when I typed all this in, I got 72.92. And so what we're saying is, this is kind of what it means. We're saying that we are 95% confident that the true average, the true amount that they actually spent that day is between $67.08 and $72.92. So that's kind of your range of what you think the true actual is. So you have your sample, but obviously your sample isn't the true population. It's just of what you had. Now, if we want to make our range smaller, there's two things that you can do. You can decrease your confidence level. So you could say maybe you're 90% confident. So that'll give you a smaller range of values. But it also doesn't sound as good to say you're 90% confident compared to 95% confident. Probably the best way to make this number smaller, the range smaller, is to increase your sample size. If you increase your sample size, that will decrease that range if you wanted to make it a little bit smaller range. This one isn't too bad. It's just within about $5, $6 of each other. So that's not too bad. But depending on the situation, you might want that to be a smaller range. So two ways to do that: increase the sample size or decrease your confidence. Okay, let's take a look at another one. Okay, so same idea here. It says, suppose a random sample of 50 units of the same materials normally distributed with an average tensile strength of 39.2 KSI and a standard deviation of 3.1. Estimate the mean tensile strength with a 99% confidence. Okay, so again, 39.2 was my average. The 2.576, I got that from the notes here, 99% confidence intervals. That's why I used the 2.576 from that chart right there. All right, 3.1 because the standard deviation divided by the square root of the sample size. Other sides exactly the same except for a plus sign. And then you type those in, that gives you your confidence interval. So you're 99% confident that the true average tensile strength lies between these two. Okay. All right, so that's pretty much how you do it. Not too difficult to do, again, just using the formula. One other thing from this section is finding the minimum sample size, and it's kind of based off this idea of error. And so it's a good time to talk about this, how many you should have in your sample. So the sample size is n, okay? This would be the minimum you should have to get the results you want. Z is your confidence interval. That's going to be your decimal. Like up here, we use the 2.576 for 99%. Okay. This is your standard deviation. And this is that error. And they're going to tell you how accurate they want it to be in the problem. And I'll show you in that. And then you type all this in, make sure you square it, and that'll give you that minimum sample size that you should use. Okay. So on this example right here, our minimum sample size should be, okay, we're looking at executives at a car dealership want to estimate the average age of the customers. They want to be 90% confident that their mean age is plus or minus 2 years, so within 2 years of the sample mean. If the standard deviation is 12 years, how large should the sample be? So the Z value, again, the Z value comes from 90% confidence. So since they said 90% confident, I'm looking at 1.645 from the other side there. So that's going to go here, 1.645 times the standard deviation, which is 12, divided by that error. They said they want the error to be 2, and then you're going to square that. Okay, so all you do is basically type that in. I got a minimum of 97.4. Okay, so their minimum should probably be, 98 as what they would want that to be. Okay. So that's the smallest, so 98 or more should be in their sample size. Okay, and so that's calculating minimum sample size to get a good reading on what they want to be. Okay, so confidence intervals, minimum sample size, that's what's in section 11.5.